Here's some sample code that just plays around with pointers. And I have to tell you that this demo suffers from the same problem that all first pointer demos suffer from, which that it is utterly pointless. And I'm just going to confess that to you. I'm going to show you the mechanics and the syntax of how to get pointers and how to use them, but you would never do this. If you have a perfectly good integer a, you would just work with a. Why would you make a pointer to it and then go through the pointer? Where pointers become useful is when, for example, you pass them down to a function or you keep them in a member variable and then you use them again later. Then knowing how to go through the pointer to get what you want back from the original fundamental type or the original object is a useful thing to know. That sets up a lot of complexity for a first demo, so we do it all together. So hopefully this is pretty straightforward. I make myself an integer called a, print out its value, make a pointer to that very same integer by using the address of operator. And then I use the pointer star PA to change the value that the pointer points to 4. Since the pointer points to a, this also changes a's value to 4. There's only one piece of memory. You can just talk to it two ways. You can call it a, or you can call it star PA. And I make a different integer. And now I change my pointer PA to actually point to B. And of course its name means nothing, right? So it's called PA, but now it points to B. So if I take the contents of PA and do a plus plus operator on them, B will be incremented from 100 to 101. So here when we print out the contents of PA, it's going to print out 101. Works with objects too. So here I make a person called Kate and a person pointer called pKate is equal to the address of that object Kate. And then this is kind of the long way. I can say the contents of pKate, wrap that in brackets, and then dot set number. And as you can see, the compiler, I've got no error messages here. It knows that that is a person function. But I can also use the arrow notation. So here where I'm using a solid object Kate, I use the dot notation, and here where I'm using the pointer pKate, I use the arrow notation. pKate points to get name. The same thing's going on over here with number. And then we have some references. Integer reference RA. Now unlike a pointer, you can't just say, oh, I have this integer reference and I'll tell you later what it points to. You have to say is equal to, in this case, A. Then if I change RA to 5, that will actually change A to 5 because RA is just an alias now for A. You saw this when variables were passed down to functions. The parameters were passed by reference. That when you changed the local variable inside the function, it actually changed the value of the parameter back in the calling code that had been passed down by reference. That's what reference means, that you can kind of change another place, talking to it with this different name. You can have references to objects as well as to people. So here I make a person reference to that same Kate object and call its set number, and then I can call its get name. And notice, because it's a reference, that I'm using dot notation both for the gets and for the sets for all the member functions, which for many people is more readable than the pointer notation. Let's quickly run this just to prove that everything does what you think it will do. So A is 3. Let's just line these up. A is 3. When we make the pointer PA and then change its contents to 4, A becomes 4. We make the pointer PA now actually point to B, and then we increment it. When we print it out, PA becomes 100, that then got incremented to 101. So it's not touching A anymore, it's only now touching B, because that's where the pointer points. With the objects, we have a 234 for my arbitrary number, and then using the pointer we change it to 235. Print it out both ways. We get 235 both ways because they're, again, the same piece of memory, no matter how you talk to them. When we set RA to be A, and then change RA to 5, and then print out A is now 5, because RA is just an alias for A. And similarly, when we make RKate to Kate, and then set its number to 345, print it out, it prints out 345. I have code here that's commented out, and let's kind of go through and talk about how the compiler would help me if I absentmindedly wrote this code. Here, I declare a pointer, and it's sort of foreshadowing that it has the name bad pointer. And I don't set it to the address of anything. I just say, la la la, it's an integer bad pointer. And then I try to use it. I try to go through bad pointer and put 3 in there. Also down here, I try to go through bad pointer and get the value to print it out. If I run this, a bad thing happens. And specifically, the variable bad pointer is being used without being initialized. So we'll just put that to stop. I told you that when I read the code, but you also notice that it sort of blows up when the application runs, and that's a really bad plan. I can make this a little better if I initialize my bad pointer to null pointer. It's a C++ 11 feature. If you're not using Visual Studio 2010, you can't use null pointer, but Visual C++ 2010 Express understands this C++ 11 feature, so it's all set. Now, if I just make only this change and run it, things don't really get much better. After all, it still doesn't point anywhere, right? So we do still, unfortunately, go boom. But you notice we're going boom in a nicer way. It's actually possible that we could send an error report. I'm not going to. And that this might be a less severe situation. In fact, here, we throw a null pointer exception that I could handle. We haven't done exceptions yet, so I'm not going to dwell on that. What's really important about initializing your pointer to null pointer is that you can test for null pointer very compactly. So I can come here and say if bad pointer I'll use it, otherwise I won't. If I run this code, we don't blow up. The if kept me out of this block and prevented me from trying to dereference, that's what this process is called, prevented me from trying to dereference the bad pointer. Now, you might think, well, it was just the if that helped you out, so let's take the equals null pointer back away and run it again. We're back to the very bad thing. Setting it to null pointer is what enables me to test whether, in fact, it's a null pointer or not. When a pointer has the value null pointer, or null putter, as some people like to pronounce it, this if will return false and will be protected. When it has random bits that happen to be in that location before, it won't be protected. Any non-zero number comes out as true, so the if bad pointer will say, oh yeah, we're good, and go in here and try to dereference the pointer, and then your program will blow up. So if you're going to use a pointer, you need to be sure that it was initialized. One way to be sure is to declare them and immediately give them a value, as you saw right here. But another way is to declare them and immediately give them the value null pointer, and then always check to see if they're null pointer or not before you use them. Let's uncomment some bad reference code now. Pretty much the same thing, but an important difference. There's red wigglies right here. There wasn't here. Compiler's fine with you just declaring pointers and not initializing them to anything. Let's put that back before I forget. It's not fine with you declaring a reference and not initializing it to anything. So you can't make this mistake. And there's no way to test, is this a null reference? Because there's no such thing as a null reference. References have to be initialized pointing to something real. And that's one of the ways that they are simpler, because you can't, oh, I have to initialize, I have to check if it's null yet. It's not optional. It will be initialized. It won't be null. You will be able to use it. That's also sometimes the reason why you can't use references, because sometimes things are optional and you don't know if they're set or not. When you can use references, I prefer to use them. They're simpler. You can use the dot notation instead of the arrow, and you don't have to check to see if they're null or not. But that's exactly why you also sometimes can't use them.